Awesome. All right. So yeah, my cover slide looks a lot like Kellen's because really this is a continuation of her presentation. So what I'm focusing on are primarily three different, well, the latter three pillars of the Oracle architecture in Azure. Kellen went through compute, storage, and the sizing assessment. What I'd like to go through is data protection, otherwise known as backups, service protection, otherwise known as high availability, and business continuity, otherwise known as disaster resiliency. But first, what I want to talk about a little bit is familiarize you with some of the redundancy mechanisms that are already in Azure Cloud. Just kind of hopefully go through them quickly. I do want to make sure not to run too long on my slides, but I have a bad habit of doing that. So let's go through the prerequisites a little bit first. I want to first just mention how fault isolation is handled in Azure. In other words, how geographically everything is located and organized within Azure. We'll talk more about storage redundancy levels, and then specifically two relevant Azure services in this whole space, which would be the Azure Backup Service and the Azure Site Recovery used for DR, that service as well. We're going to talk about those just real briefly. So fault isolation. I don't know how to put it. I mean, I believe Azure still has the largest number of regions, and for that matter, data centers. It's the largest cloud out there. Something like 60 different regions. I forget, maybe it's only 40 or 50, but there are, I know, 20 different regions also being built. So it's going to grow significantly. So just to put it in one way, fault isolation, a VM, a virtual machine resides within 0, 1 or more fault domains, also known as availability sets. Okay, so in other words, when you have, say, 2 VMs or more VMs inside an availability set, Azure itself will work to keep those VMs in different fault domains to ensure that if anything takes out, the hardware within a data center, the other VM that's in the availability set will survive. So fault domains, they're up to 5 fault domains. No, sorry, 3 fault domains. There's up to 3 fault domains within an availability set, and up to 5 different update domains, which have to do with automated updates and such. I really don't, in Linux, even though for Red Hat Linux, we do have automated updates available. For Oracle Linux, there are no automated updates available. That's purely bring your own update kind of a territory there. So I don't really mention update domains a whole lot. But anyway, a VM can be placed within an availability set with other VMs, and that makes sure that one of those VMs will survive. Okay. Availability sets aren't used that often, though. And really, it's to be understood that an availability set is a grouping of VMs within a data center. Now, a data center is, obviously a building somewhere in the world, and an availability zone is 1 or more data centers together. It could be just as low as 1 data center, but for most of the larger regions that we have, a data center is one of many data centers that are within an availability zone. And an availability zone is defined by network latency. So all these data centers have to be within a certain network latency of one another. I believe the cutoff point, although it's not published, I believe the cutoff point for an availability zone is 1 millisecond network latency. And I find that between most of the AZs and most of the regions, certainly in North America where I work most often, I do find that the network latency between AZs in most of the regions is well below 1 millisecond, like down around 200 microseconds to 300 microseconds. But there are some geographic anomalies. I know of one in the DC area where the AZ is like 30 to 50 miles away from the other two. So one of our regions in the mid-Atlantic area has an AZ that's kind of way out there, kind of well known or notorious. Any rate, so one or more data centers make up an availability zone. Either 0 or 3 availability zones make up a region. In other words, either a region has availability zones, and if there are, there's 3 of them. Otherwise, a region just has 1 or more data centers, no availability zones. So a good example of a region is the same thing as in the Oracle Cloud. A region would be, one of our regions near Washington, D.C. or San Jose or Phoenix or any one of those places. So a region, again, is defined by network latency, and I don't know what the actual technical cutoff is, but I believe it's about a millisecond again. So to communicate between any 2 VMs anywhere within a region should be well less than a millisecond. And then last, there's a geography. Geography isn't really for fault isolation. A geography is more for data sovereignty. We want to make sure that all of our geographies, we haven't gotten there yet, but we want to make sure that all of our geographies have a primary and a secondary region for failover. Okay. Again, we haven't gotten there yet, but we're working on it. So it's a big world out there. So that's kind of fault isolation in a nutshell. The next best and fun topic to talk about is storage redundancy levels. To put it bluntly, nothing is stored within Azure. There's no storage in Azure that is less than 3 copies of data, mirrored twice, in other words. And that's known as LRS, locally redundant storage. So all the different kinds, I tried to make up a little table here, and really I wish I'd deleted this slide because it doesn't make too much sense if you're new to Azure. But anyway, locally redundant storage is the lowest level, and that's always 3 copies within the local region. It's not necessarily the local data center, but certainly within an availability zone. That's what's meant by local. Now, the next level up is zone redundancy, and I'll describe that in more detail coming up. And then we have the geo, in other words, across regions. We have storage levels that are redundant across regions, and I'll go into each one of those. The type of storage that is managed as LRS and ZRS are the ones that we typically like to use, as Kellen mentioned, for most of our Oracle databases. It's relatively inexpensive managed disk, and again, and quite well protected. LRS by itself is pretty awesome protection. ZRS is even better, and those are the type of storage that we like to use for Oracle. Azure files are file shares. We don't necessarily use Azure file shares very often for standard Oracle storage, for database storage, but we do use it, as noted here, for archive read-log files or backup set files. So it's good to know what types of storage we have out there. And these are the types of storage, either Azure file shares or managed disk, that are used very often for Oracle databases. Okay, blobs, occasionally, that's the lowest level of storage. The standard general purpose storage or premium block blob storage can be mounted over NFS to a Linux server quite easily. And that's not suitable for anything other than archive read-log files or RMAN backups. We don't want to do transactional traffic down to those unmanaged blobs. We want to do those to things like managed disk or, again, some of the premium file shares. But the standard blob storage is just there for cheap, redundant storage that's pretty fast, but there's nothing managed about it. There's no managed backups for them. Okay, so the redundancy. LRS is all within a data center, and we synchronously update 3 copies of data. Boom. So it's like RAID 1.1, if you will. Zone redundancy is similar to that. It's 3 copies updated synchronously, but each of the copies are located in different availability zones, thus different data centers. So, extremely durable data. Now, to go beyond that, and none of the managed disk has this level of redundancy, but the unmanaged blob storage, again, that you can use for general file system storage, does have this, and this would be geo-redundant, and that is it's LRS in a primary region, and then it's asynchronously replicated to a secondary region where it's LRS as well. So the number of nines for durability just gets longer, 16 nines. So a total of 6 copies of data with geo-redundant storage. And then geo-zone redundancy storage, just to, kind of go even further. And that just simply means in the primary region, you're using ZRS, which is redundant enough, but just to make it even more redundant, we do an LRS redundancy, asynchronously copied in the secondary region. So both of the geo levels asynchronously copied to LRS in a secondary region. And then the only difference really is what's in the primary region, either LRS or ZRS. So when you absolutely positively have to make sure that it's there, these are the ways to do it. And there are no options to ever write a single copy or a double copy of data to disk. It's always at least triple copy. The other thing too is I don't mention it on the slide here, but encryption. There is no storage option in Azure that isn't at least encrypted at the storage layer. Plain text doesn't reach, or plain anything doesn't reach storage in Azure. There is at least a base level of Azure managed key storage at each of these base levels, and you can also add additional encryption on top, either at the guest OS level or certainly at the application level, like Oracle's transparent data encryption. But just for the sake of, there's always at least one level of encryption, and frequently 2 or 3 levels of encryption going on inside Azure. Okay. One thing too about the availability of the data in the secondary region, if you just use GRS or GZRS, then that secondary region is only available after a failover has been declared by Azure. But however, if you want to get access to that data in the secondary region, say to do something like Active Data Guard does, have a read-only set of data in another region, then you can declare the storage to be read access GRS, RA GRS, or RA GZRS. So you can have availability at all times to what's in the secondary region. So obviously there's a price difference there. So just so you know. Okay. Azure NetApp Files is another type of storage that I'm sure Kellen mentioned. It's licensed from NetApp, but it's Microsoft technology. It's native to Azure, and it's at present built so that it has to reside in one of the data centers that's in a region, but it's available across all data centers and availability zones. Basically, it's unaware of availability zones within a region. That's changing over time as more of the ANF hardware is being rolled out. Quite frankly, it's a hardware issue. We don't have enough hardware at present to have ANF in all availability zones of all regions. It's being rolled out. But as soon as we do have uniformly across the way ANF hardware in all the availability zones, then it will become AZ aware. But right now, when you allocate a VM and you allocate ANF storage to it, you do want to work with support or work with the certain teams within Microsoft to make sure that your VM is in the same AZ as ANF, just because it helps a little bit on latency. So anyway, ANF, I'll say it's awesome storage. It is all NFS mounted. It could also be SMB mounted for Windows, but NFS for Linux, and it is typically our lowest latency storage, downwards of about 200 to 300 microseconds latency. So that's pretty good stuff there. And as Kellen may have mentioned, it's also extremely high throughput, IO throughput. currently around 4,500 or so megabytes per second. By the end of the year, it'll be up around 10 or 11,000 megabytes per second. Anyway, so ANF also comes with its own data protection mechanism. It's basically called cross-region replication. So volumes that are in a primary region can be copied across to other regions, or in the future other zones, for that cross-zonal awareness when zonal awareness becomes a part of ANF. So ANF, very durable, very fast, and very resilient. Okay, the service called Azure Backup is fully integrated with Oracle Database. It's not the standard. In other words, when a VM is enabled for Azure Backup, it's done by simply calling for an initial backup within the Azure portal or any of the APIs, and boom, snapshots of all the storage in a VM are taken. Integrating Oracle Database with Azure Backup does take some additional steps. There is some setup to be done. On the Linux side, there's a configuration file to set up to point out where the Oracle databases are, how many there are, etc. And it's also important to remember OS authentication, because we use OS authentication to connect as the sysbackup role or user, or as a user enabled for sysbackup only, not sysdba. So, for those of you who would, want to use the standard Azure backup to back up your Oracle databases, it's again fully integrated, but you do have to do some setup, and you would have to want to set up an OS account that you would enable for Backup DBA group. And if you haven't done that before, hey, we can do it now. We do have an option in the works on the roadmap to instead authenticate Azure Backup to the Oracle database using Azure Key Vault, but we don't have that, and it won't be available for probably until the next calendar year. But we take daily snapshots with Azure Backup of all attached managed disk. The images are incremental, so that first backup is a full backup, but all the subsequent ones are, incremental. They only capture changes since the last snapshot backup. And all those snapshot images are stored locally for about 2 days. That's the default period. They can be configured to be stored locally up to 5 days. And the idea behind that is for instantaneous restore, because they're local. But obviously, they're not very durable if they're local. So the other thing that happens immediately after a snapshot image is created, it's copied to an immutable recovery services vault, which is a storage account within the region. And it can be, by default, retained in that vault for about 30 days. You can configure it. It costs more to store it longer. It costs less to store less. Typical restore actions include restoring the entire VM, either back to the VM that did the backup or to a new VM. In other words, cloning. So you've got that option to go either way. You can also restore the individual disk images back to the same VM or a different VM if you wish, but that isn't codeless. The way the Azure GUI will handle it is it'll download a bash script for you to edit, just to for you to decide which disk images you want to restore and to where. So the restore action number 1 can be codeless, done entirely through the GUI, restoring the entire VM either to the VM that you backed up or cloning to a new VM. That's all without code. But the second option does require some either Azure CLI knowledge, which is Bash Shell, or Azure PowerShell knowledge, for those of you who know PowerShell. Azure Site Recovery is the default DR mechanism for Azure. And the basic idea here is that there is a near real-time and continuous asynchronous copy of all storage attached to the VM to a storage account nearby. It's geo-redundant, that storage account, but basically the entire stored image of the VM is copied to somewhere else, essentially. And upon site failure, VMs can be instantiated in a secondary region at failure time from the latest image on the geo redundant storage account. So, you must have all figured out, wait a minute, this is all asynchronous. Well, yeah, it's not part of the Oracle application. It's making copies of the storage asynchronously underneath Oracle. So Oracle's not aware of this as it's going on. As a result, this mechanism really isn't guaranteed RPO 0. There is the ability to create checkpoints to limit your RPO, but it's not going to be RPO 0. And the other thing is this mechanism has a data change limit of currently 54 megabytes per second, to be increased to 100 megabytes per second soon. But the thing is that this mechanism probably isn't the best DR mechanism for you to use for your Oracle databases, most of which, at least the production ones, probably have a requirement for no data loss or RPO 0. So we strongly recommend in Azure that you use DataGuard or some other Oracle mechanism for disaster resiliency rather than use the Azure Site Recovery. We are working with the ASR product group to try and raise that data change limit and add other features to make this more suitable for database workloads. But for now, Azure Site Recovery is probably a better mechanism to use for your app tier servers, your web servers, your application servers, those kind of machines that don't have such a high data change rate. So just wanted to give you that note. So now, having gone through those prerequisites, let me get on to some recommendations for running Oracle within Azure, specifically on the topics of backups, high availability, and disaster resiliency. So first of all, with data protection and backups, when you think about it, there's really, and this is true on-prem as well as in Azure Infrastructure as a Service, but there's two possible kinds of database backups: streaming, which is dominated by Oracle RMAN, and rightly so. Streaming backups, that's when you're, just like the word streaming suggests, you're copying bytes from here, sending bytes to there. That's exactly what's happening with RMAN, and that's how RMAN was built. It was originally built to support tape drives. Nowadays, it supports, virtual tape libraries or just writes to disk. Okay, there's no dependency on the type of storage. RMAN works everywhere. And again, based on the concept of backups being streamed to sequential tape media. Two destinations, virtual tape libraries. And in the Azure Marketplace, we've got several of the VTLs you might be familiar with: Commvault, Veeam, Veritas. I don't know if data domain's in there, but it's worthwhile checking, etc. So depending on the type of VTL, if you wish to use it again in, say, Azure, as you do on-prem, then feel free if it's available. A lot of folks prefer to kind of cut out the virtual tape library and just store the Azure backups, using device type disk. And you've got the option for that. I strongly suggest, unless you've got severe performance requirements and need direct attached disk, I strongly suggest getting the backup sets off the VM as soon as possible. In fact, immediately. So I strongly suggest using file shares. In Azure, we've got several different types of file shares that you can use. There's actually more choices than this, but in basic, I just kind of list here a continuum of 3 different choices for file shares in Azure, starting with the least expensive and pretty fast, but also mainly the least expensive to the most expensive and the most feature packed. So the least expensive is writing over NFS, writing down to Azure Blob Storage, unmanaged Azure Blob Storage. We've got that as a file share. Azure Files is a managed solution that ranges from inexpensive to more expensive. It can have its own backup utilities by snapshot set up, very similar to what I described for Azure Backup. Azure Files has that for the file shares that you create. So that's another option. In fact, I really like the option for Azure Files that has that automated and controllable backup. So I tend to recommend that very often. But in addition, we also have the option of Azure NetApp Files, which, as you remember, that's one of the options that we typically use for the Oracle databases themselves. So Azure NetApp Files is kind of our high-end file share option. It's very fast, and it has its own backup solutions. So it's very durable as well. So with streaming backups, you can either do SBT, device type SBT, to one of the virtual tape libraries, or you can use device type disk to write to file shares. You can also write to local disk, but then you have to get it off to, say, a file share somewhere. So I typically recommend, if you can avoid it, don't write to local disk, write it to a file share originally. So that way it's away from the blast radius of whatever takes out the VM. Okay. The other option, though, that everyone has to consider as their database grows is storage level snapshots. And you're thinking, well, I don't agree. I don't think that that's an option that everyone has to consider. Well, if your database grows, the laws of physics say it takes a lot of time to copy data from here to there. My own personal rule of thumb, just a rule of thumb, is that it takes anywhere from 1 to 2 terabytes an hour to stream an RMAN backup. Some people may do better, some people may do worse, but I use that rule of thumb, 1 to 2 terabytes an hour. So I know if I have, say, a 20 terabyte database, it's going to take me anywhere from 10 to 20 hours to do a full RMAN backup, or even more importantly, a full RMAN restore. So if I have 20 hours to do a restore, if my RTO allows me 20 hours to just restore the database, never mind start the roll forward recovery, fine and dandy. But, if you've got an RTO of, say, 4 hours, you've just really exceeded that RTO with your RMAN full restore. Now, obviously, RMAN could do other things besides a full restore. It can do a partial restore. It can even do block restore. But the thing is, how often do you use those? And how often do you, in comparison, how often do you do a full restore? In my own career, 38 years in IT this year, you tend to remember the bad times, don't you? I've done at least a half a dozen full database restores of a production database. I know I've done partial restores. I don't remember them so well. I don't think I've done them as often. So anyway, that's just my experience. But everybody has to, at some point, if their database is growing and you start to exceed your RTO, you really have to consider another way of doing backups. Because again, incremental backups, they don't reduce the time to restore. They only reduce the time to take backups. In fact, incremental backups can arguably lengthen the time of recovery. So you really do have to think about another method of backup and restore, and that would be storage level snapshots. Now, obviously, if you're taking snapshots of your storage, it's dependent on the type of storage you're using. Again, in Azure, we've got typically one type of storage is the managed disk. Typically, premium SSD is what we recommend. Azure Backup is integrated with Oracle Database, as I described earlier. Azure NetApp Files has a facility called ANF, or Azure NetApp Files Backup, and it uses a component called AZAC Snap, and it's augmented with the mechanism called cross-region replication. Silk is another type of storage. It's a third-party vendor inside Azure, and it provides very high performance storage based on clustering together different Azure VMs that have NVMe storage on them. Silk, I've never personally done backups with Silk storage level snapshots, but Silk has not only the capability of using snapshots to take backups, but also using thin copies of snapshot images to create clones. I mean, it's a very, very, very powerful tool set. Unfortunately, as far as I know, it's mostly, Silk mostly provides an API. I could be wrong in that, but they mostly provide an API, and you have to build your solution for doing backups and restores or cloning. I'm sure that can't be right, but that's as far as I know. I just don't know enough. At any rate, streaming backups, RMAN backup sends the backup sets to either device type SVT or device type disk. 3 types of backups are available: full or level 0 incremental. Mostly this is for folks not familiar with Oracle. Level 1 incremental or archive log backups. Okay, so that's pretty much how RMAN does its job. Each type also includes other additional files such as control files, parameter files, BCT files, flashback log files. All those things get swept into a backup as well. For streaming backups, some of the choices for backup media, I did mention you can use managed disk as backup media, but it's attached to the VM. It's not that great to keep your backup sets local. You want to get them away from disk, but sometimes to back up as quickly as possible and disrupt the database less, you might want to stage it on local disk and then copy it later off to file share. So anyway, one of the characteristics of managed disk is it attaches using SCSI. It can handle up to 4,000 megabytes per second of throughput. I've got a link here. When you get the slides, I've got a link to the documentation detailing, the characteristics of performance characteristics of managed disk. And I also recommend too, if you're trying to optimize performance, use LVM striping. An individual managed disk might have upwards of 4,000 megabytes per second. Striping multiple managed disks together creates a logical volume with even higher throughput. But other options for streaming are, again, blob NFS, uses the NFS version 3 protocol. You can expect about 1,000 megabytes per second, and here's a link to more documentation about that. The Azure Files shares have kind of a standard and a premium option. SMB is the only thing that's Samba, which in Linux terms is called a CIFS protocol. So you can definitely mount Azure Files standard Samba to Linux using the CIFS protocol. You can expect upwards of 300 megabytes per second. And the Azure Files standard is the one that has its own automated backups. The Azure Files Premium doesn't. It's available with NFS version 4.1 as well as Samba, and it can handle upwards of 1,200 megabytes per second of throughput, but it doesn't have its own automated backups. You have to kind of roll your own the way you do with blob NFS. Yes, automated backups for Azure Files Premium are on the roadmap. Just don't know when it's going to come. Azure NetApp Files, as I mentioned, is the premium option. You can use NFS version 3 or version 4.1. They themselves say you can expect upwards of about 1,700 megabytes per second of throughput, and they do have automated backups. So there's a lot that comes with that package. One thing too that people have found is that there's a open source utility called Blob Fuse that's available. The Fuse libraries are, again, open source. This is not a supported Microsoft product. It's supported by the Azure storage team, but on GitHub, they don't have to respond to your request. It's all by voluntary. So I don't recommend the use of Blob Fuse very often. It's pretty slow, and the reason that it's slow I'll show on the next slide. And it's just, again, it's not supported by a large organization. The issue with Blob Fuse is that the Fuse protocol uses local storage as a temporary staging point. So when you think you're reading and writing to a file share, you're not actually doing that. RMAN thinks it's writing directly to the file share, but in reality, the Fuse library is writing everything that RMAN wants to write down to a staging area, and then the Fuse library copies the data across to the file share. So you're actually doubling the number of reads and writes that you're doing, the number of IOPS for your backups. That's one reason for the slowness. And then, of course, the speed of this staging area. There's a lot of different choices for it. The speed of the staging area really impacts the performance. Normal file shares, you want to write to the file share, you just write to it. And NFS or SMB or CIFS, that is, handles that. But Fuse is different. So that's, again, why I recommend against using Fuse unless you don't care how long it takes to get stuff across. Okay, recovery point objective. Just wanted to mention some of the metrics that you want to be aware of. Tolerance for data loss recovering from a failure. Remember that streaming backups or any backups of any kind can only be recovered to the point in time of the latest backed up archived read log file. That's not RPO equals 0. That's RPO equals, well, that's RPO equals, say, archive lag target. The Oracle parameter archive lag target forces time-based archival of redo. So really, whatever you set archive lag target to is your RPO. Like 5 minutes, 10 minutes, 15 minutes. That becomes your RPO, because if it's not archived, then it can't be backed up. Recovery time objective is the expectation for return to service after a failure. Okay. When the time to fully restore a database using RMAN exceeds the RTO, it's time to consider replacing RMAN. Heretical as it sounds, that's why we discuss storage level snapshots. And again, when the database is stored on managed disk, you want to look at the documentation for Azure Backup integrated with Oracle database. If you're stored on Azure NetApp Files, you want to look at the documentation for Azure NetApp Files Backup. And for databases stored on Silk, I don't have links, but you would want to look at the REST API for Silk. Okay. With Azure Backup, and same thing with Azure NetApp Files Backup, there's an agent that runs within the Linux VM. It runs a prescript before the snapshot, and that prescript runs under SQL+, connected as sysbackup. It flushes transaction logs to disk, and then it enters the database into backup mode. So really, it runs 2 commands: alter system, archive log current, which performs a checkpoint as well. That flushes everything to disk and flushes the logs to archive. And then it runs alter database begin backup. There's also a corresponding postscript that runs after the snapshot, and it runs alter database end backup, and then runs another alter system archive log current to flush everything out again. Each of these 2 scripts writes a message to your alert log, so you can verify that they're actually being executed. And from that timing of those messages in your database alert log file, I know that no matter how many databases you have on your system that are being backed up using Azure Backup, the snapshot always takes 5 seconds, 6 seconds, 7, somewhere in there. You can verify it using your alert log. Pricing, there's a link for it. The pricing's not too bad. It's something like, I don't know. Anyway, the pricing's not bad. It's typically, it works out for something like 10 terabytes to maybe $100 a month, something like that. Okay. Step-by-step documentation for setting up Azure Backup is here. And there's some brief videos. And again, when you get my slide deck, the videos will be shown. The link to the videos is here. So I'm not that good at videos. They're really primitive. Be gentle with the comments on the videos. So, and the third of 3 videos, the first 2 depict setup. The third one depicts database restored to a new VM, basically cloning. There's also a verification script for diagnostics, either proactively or reactively, that you can download from GitHub here to verify that you've set up the Azure Backups integration to Oracle correctly. So that verification script is there as a help aid. Okay. For Azure NetApp Files, to use ANF Backup, it's currently in preview. So there's a link to the sign up form there to look at the preview product. The snapshots of the volumes are captured either manually or scheduled. And basically there's enough information here for you to get started with that as well. Just like with Azure, the standard Azure backup, Azure NetApp files backup copies the snapshot images to immutable storage, which, by the way, both mechanisms work really well as ransomware protection. When you copy, data, backup data to immutable storage, that's a good thing. Nothing can get at it. That's not the kind of thing that typically happens when you back up, to device type disk to a file share. Something can get out there and play with those backup sets. So it's not good ransomware protection, but this stuff is. Snapshots can be retained locally, just like with Azure Backup, and snapshot images can be retained in that immutable storage account for a longer term. Okay. And I was describing here what happens mostly to folks without an Oracle background, but when a database is in backup mode, normal database operations proceed as usual, with two exceptions. The SCN is frozen in the database header, and the entire block is written out to the redo stream after the first change after the begin backup, instead of just the change bytes, to protect against the fractured block syndrome. So the longer a database is in backup mode, you would expect to see the redo stream increase dramatically. But again, with the Azure backup snapshots and Azure NetApp files backup snapshots, the database is only in backup mode for about 5 or 6 seconds. So redo stream doesn't change a whole lot, and the database operations are not impacted. There's no quiescing, nothing like that. Interestingly enough, we do the same thing for Sybase, SAP ASE, and there is a need to quiesce parts of Sybase database, but not for Oracle. Okay. Yeah, so just mentioning, the volume generally can increase when the database is in backup mode, but with storage level snapshots, we're only in there for seconds. So there's not much, that gets changed. Just explaining, the last change number field, that's the SCN field that's in data file headers. Just explaining how that works. Alter database begin backup freezes it so that the roll forward recovery begins from the moment when begin backup ran, and it replays all the transactions. Just for your own purposes, if you want to see Azure Backup in action, I have a fully automated accelerator script written in Bash that uses the Azure CLI, and it fully automates the creation of a single VM with a configured Oracle database running OEL. You can specify the version 12.1, 12.2, 18.3, or 19.3. Those are the images that Oracle has posted to the Azure Marketplace. You can use either managed disk or premium SSD storage or Azure NetApp files with the script. And Azure Backup is fully integrated. Everything is all set up, and you have an Azure Files standard file share configured to receive your archive ready log files. So you can do all the playing around you want with the VM and database that you can create using this script. So there's a link there to GitHub on this page. Okay, that's past backups. Let's get to the real fun, high availability. Architecting redundancy for the purpose of minimizing downtime from service outages, whether they're planned or unplanned. Two possible architectures for service protection. Either a cluster, that is one or more nodes, well, two or more nodes sharing the same data storage, or replication, one node replicating to another, and they're completely independent of one another except for that network link. Okay, so obviously what we're seeing here is a picture that could be applied to either RAC or Linux HA clusters on the left, and on the right it could be applied to either DataGuard, Golden Gate, Quest Shareplex, Stream. Any one of those replication options can be applied, can be illustrated by the diagram on the right. So the idea here is that when one of the nodes that the database service is running on goes down, the other node picks up and takes off. And Oracle's architecture obviously Oracle's recommendation is to use a clustered RAC solution at a first layer, and then behind that layer for disaster resiliency, use DataGuard. But as you're all aware, Oracle support has prohibited the use of RAC in any public cloud other than Oracle's. So you really don't have the option to use RAC outside of Oracle Cloud or on-prem for that matter. And that's actually a good thing, because to be perfectly honest, as we all know, RAC really isn't a great HA mechanism. Given that Oracle provides 3 different HA mechanisms, being DataGuard, Golden Gate, and RAC, RAC is easily the distant third in terms of effectiveness. DataGuard and Golden Gate are far more effective for service protection than RAC. RAC was built, it was first designed in the 1980s for scalability, for a good reason. In the 1980s, all computers were single CPU. There was no such thing as multiprocessor and multi-threading. Those technologies came into being throughout the 1990s and the 2000s. First, the multiprocessor. By the year 2000, just about every server was capable of supporting multiple processors. But things really took off in the 2000s with multi-core processors and then multi-threaded cores. So nowadays, it's not unusual to have several hundred logical CPUs, hyperthreads, running under a single OS image. So essentially, over time, what happened was the reason for RAC, which is an excellent product for what it does, the reason for RAC, which was to support database workloads that are larger than any single server image, essentially it went away, or it just became a very small niche. Because now we've got servers that have several hundred, the equivalent of several hundred CPUs. You can argue whether a hyperthread or a logical CPU is the same thing as a physical CPU. Let's forget about that. Let's just talk about multi-core systems. Multi-core, multi-CPU systems, you've got easily upwards of 128 cores on most server platforms, if not even larger. So the market for RAC, the original market for which RAC was designed, went away essentially around the year 2000. So what Oracle did was brilliant. They pivoted. They started selling RAC as an HA option and marketing it as an HA option, to the exclusion of their other HA options, such as DataGuard. So we're going to talk about all of this. So we've got on the cluster side a couple different options, such as Linux pacemaker chorusing, which is the descendant of all those HA clustering solutions you're familiar with from years ago, like Veritas VCS, HP Service Guard, IBM HACMP, etc. Linux pacemaker chorusing is the descendant of those for Linux. It's open source. Oracle has an option very similar to pacemaker chorusing called RAC One Node. Okay, same thing. They're both active passive options. So there's one active node, one passive one, and so the service fails over from one to the other. Oracle RAC is kind of unique in that it's an active cluster, and that's what's there. On the replication side, we have multiple active passive options, including the always excellent Oracle DataGuard, single master replication, such as Oracle Golden Gate, Quest SharePlex, HVR, Stream, all those, and Azure Site Recovery, which I've already poked some holes in, the viability of. Also, we have an active option with replication, and that's Golden Gate, Quest SharePlex, etc. So if I remove some of these options because they're not supported or otherwise, not supported, or really not recommended, we've got these options to discuss. Clusters, we've only got really pacemaker chorusing to discuss. And replication, we've got DataGuard and Golden Gate. When you think about it, I recommend this more as an exercise for you to do at home as homework. This is just this is really best done in a spreadsheet, not on a slide. I've only got 5 different unplanned outage scenarios listed here. Yeah, I mean, really, there should be several dozen that you can probably think of. But if you do this yourself, come up with all the possible unplanned outage scenarios you can think of, and then enter one of those on each row of a spreadsheet, and then on the columns, mark all the different mechanisms you'd like to use or possibly could use for HA, to counter those scenarios. And then in each cell, come up with a legend. In this case, I have a legend that's based on RTO. In other words, 0 means it can't do any protection at all. 1 means it can restore service within 4 hours. 2 means within 1 hour. 3 within 10 minutes. 4 within 2 minutes, but database sessions will need to reconnect. And then 5, the highest rating, means that it can restore service within a couple minutes, including seamless application failover. Okay, so that's one way to do it. Another possible legend you might want to do is RPO based, able to restore to within 24 hours of data loss, within 4 hours of data loss, 1 hour of data loss, 0 data loss. You can also do that as well. But go through each one of your different mechanisms and score them yourself. This is how I score it, but your scores may be different. But I would say this is a great exercise to do on your own to find the relative merit of each one of these mechanisms for high availability. And I always come out with something like this. RAC does a few things very, very well. PCS does the same things as RAC, not unsurprisingly, but less well. It's a cheaper solution. But DataGuard does some things very well and some things not so well. But in the end, it comes out supporting a lot more than RAC does. And Golden Gate does some things pretty well and comes out with a very high score as well. That's my essential evaluation. Yours may come out differently, but I strongly recommend that you do this exercise to work this all out in your own head. So Azure customers mainly use DataGuard for service protection. We typically recommend a nearby standby within the same region. We call it the HA standby, plus a DR standby that's in another region. Okay. The nearby standby, the HA standby, we typically recommend that you use max availability mode and fast start failover. The DR standby, we recommend, well, anyway, I'll come up to that. So I'm just going to kind of describe, I kind of got out of sequence here. Azure customers use DataGuard. Non-mission critical workloads, go ahead and use max performance. There's no guarantees with max performance, just best effort in the RPO sense. But the reason for that is performance of the primary database is given the highest priority with max performance. Max performance means what max performance is. Availability and data protection takes backseat to performance of the primary. Max availability is probably the more common mode that's used, especially for production databases. Data loss is still theoretically possible, but very, very unlikely. The RPO is not quite 0 with max availability, but it's darn close. The availability of the database service is given the highest priority in max availability mode. Above that of data protection, that is RPO, and performance. Availability is the highest issue with max availability. So it's one of the more commonly used protection levels in DataGuard. Max protection is the one that you would think that people are, especially DBAs, would use most often because it commits to RPO 0. Absolutely, protection of committed transaction is given the highest priority. But the problem is, in order to achieve that, if either side, if either the primary or the standby or the network between them goes down, everything goes down with max protection. In other words, max protection doesn't even allow you to run transactions if the transaction can't be protected. So that's why max protection doesn't get used very often. Just something to know. Different service levels in DataGuard. I've got a script, another fully automated accelerator script in Bash that sets up 3 VMs, one with a configured primary database on OEL, the second with a standby database in max availability mode on a second node in another availability zone, and then a third very small VM in a third AZ availability zone that runs DataGuard Broker as an observer for fast start failover. So you can do a lot of great testing with this across 12.1, 12.2, 18.3, and 19.3 using this script. It takes about 40 to 45 minutes for this script to complete to set up all 3 VMs. The thing that takes typically the most time to complete is, to be honest, is running yum update against these VMs, because Oracle posted the image templates quite a while ago, and now there's been a lot of updates since. So the yum update is taking longer and longer and longer, even actually longer than it takes for the DBCA to create the Oracle database. So anyway, I've also got another script out there called that creates, similar to creating DataGuard. If you want to test out Pacemaker Core Sync, it does the same thing here. It creates 2 VMs with shared storage in an availability set, and it installs Pacemaker Core Sync on the 2 VMs. And Pacemaker Core Sync controls which is active, which is passive. And you can control, of course, Pacemaker Core Sync, PCS. There's an additional VM that I create mainly as a kind of a jump box for launching tests. It's a very small VM, just so you can, you know, check connectivity and do testing with. But those 2 scripts should give you quite a bit of playtime, if you like, within Azure. Service protection, as part of high availability, something that people tend to misunderstand or overlook. We have the old transparent application failover syntax that allowed us to specify database connect strings that specify a failover mode. And that works really great, especially with DataGuard, where we don't have a scan listener to, you know, distribute transactions or direct failover or anything like that. So that has to be encoded into the connect string, the failover mode, and where to fail over and how to fail over. But the other important thing is getting the application to disconnect, because there are a lot of times when, say, the network connection drops to the database, but the database connection may not time out for up to minutes. And the reason for that is maybe what went down was not the VM that caused the network connection to drop at a like layer 4 of the network OSI model, but rather it could be that just the database went down. And when just the database goes down, you know, it could be that the network connection remains from app servers and sticks and persists, which is how TCP/IP is built. So we need something in there, and Oracle built this a while ago. We need something in there to force the application to disconnect when it needs to disconnect. So seamless application failover requires the use of the configuring of database clients to use ONS, the Oracle Notification Service, which is part of the grid infrastructure. The GI, the grid infrastructure, is normally part of RAC, but there's a standalone version that we use in Azure called Oracle Restart. So it's a good idea to install Oracle Restart to get the ONS in Azure, and then instrument your Java clients with FAN and FCF. FAN for Fast Application Notification, and FCF for Fast Connection Failover. Most of the basic Oracle clients like SQL Plus, Data Pump, SQL Loader, they're already instrumented with FAN and FCF, but most JDBC applications aren't. So the way FAN works is that, you know, underneath the covers, your DataGuard database might be, you might be losing your primary. Here's normal operation. You might end up losing the primary database, but because you didn't lose the primary VM, the WebLogic app server stays connected, won't drop because the TCP/IP connection is still there. So the ONS in the grid infrastructure sends a message to an event handler that's attached into the WebLogic application. Okay, you get, yeah, we're stuck in this situation. So we send a message via the ONS, and it tells the client-side JDBC code to disconnect and reconnect. That's an important part of seamless application failover, because not every outage scenario involves the VM going down. Okay. Zero downtime on maintenance operations with RAC is very much an overstatement for RAC, but it's an understatement for DataGuard. Not many people know that RAC is really incapable of facilitating zero downtime or minimizing downtime using the technique of rolling upgrades on all maintenance operations. Rolling upgrade is possible with RAC for patches to the hardware, to the OS, and some specially designated database patches. But rolling upgrade with RAC is not possible for all RDBMS patches, upgrades, and even application patches. In contrast, since really it's actually Oracle 11G, not 12C, I misspeak here, DataGuard has been capable of facilitating zero downtime using the technique of rolling upgrades on all maintenance operations, including hardware, OS, database, and application. And the technique is called transient logical standby. But let me first just kind of illustrate what I'm talking about here. With a rolling software patching with RAC, what we patch is when we bring the database instance down, what we patch is something on the node software within the cluster. We're not patching the database here. Okay. So when we apply a patch and bring the instance up and then bring the instance 2 down and patch it and bring it back up, all we've patched is the OS on the node, either the hardware or the software on the node, maybe the RDBMS software as well. But what happens when we try to do database patches with RAC? Okay. So with database patching, we try to do a rolling upgrade again. We take down instance 1, we apply the patch to both the software, RDBMS, hardware, OS, and something in the database as well. Now, what happens to instance 2 when that patch hits the shared database? Instance 2 fails. It's physically not possible to do certain patches with RAC. In contrast, the DataGuard using transient logical standby. Transient logical standby temporarily converts the physical standby database into a logical standby, and a logical standby can be open for read-write activity while the primary database is pushing transactions that are SQL applied. It's inherently open for read-write activity, which is the reason it's not used that often. Because quite frankly, you can end up with bad situations with logical standbys where people are putting updates there, but not to the primary. So physical standby enforces the active passive. Logical standby doesn't, but here that's to its advantage. So we can apply a patch or an upgrade on an open logical standby database while it's still being updated with transactions from the primary. So what that looks like is something like this. Here, we first start by converting the physical standby to a logical standby. And then we can apply patches either to the software, maybe by shutting down the instance, or to the hardware, or to the database. But the logical standby, while it's a logical standby, can be patched without affecting service on the primary. Then when we're done patching, we revert the logical standby back to physical. And now we do a DataGuard switchover, just a role switchover. We convert what used to be the standby to a primary and the primary to a standby. And then we repeat the process on the old primary. We convert to physical to logical, apply the patching, revert back to physical. And if we like, then switch over back. That's a real rolling upgrade. And that's something that can't be done with RAC. Okay, so Oracle has forced customers running Oracle on public clouds to actually adopt the very best database service protection, which is DataGuard. Now, I know I must be running out of time. I don't even know what time it is. Oh, I'm 12 minutes over. Sorry about that. I'll just go through this pretty fast because I think everyone knows DR. The answer to DR is DataGuard. The most common DR option chosen is to use Oracle in max performance mode for DR. But there are situations where RPO 0 is desired even for disaster resiliency. So in that case, it is also possible to use max availability mode when you enable FARSync, which also triggers, by the way, an active DataGuard license. So you have a choice with DR. In Azure, we recommend that DR be used with Oracle DataGuard. You can also use Oracle Golden Gate. We do have customers using that for both HA and DR. But typically what we recommend is DataGuard with a local HA standby, okay, and a remote DR standby for DR, okay. Azure Site Recovery doesn't really work very well. I just want to, again, make that point. But it is there for very low IO throughput, especially write throughput databases. You can get away with using ASR. So for testing out DR, again, I can recommend the DataGuard script that I mentioned earlier. It can be used to demonstrate DR here as well. That's all I had, and I apologize for going over. I do have a listing of all the documentation references that I used in compiling this slide deck. So here's a set of links that might be useful, whatever you want to learn. And I'm open for Q&A if anyone's got any questions, if I haven't stunned you into a coma or anything like that. So I'm going to look at the chats and see what we have here. Uh-oh. Okay. Those are for Kellen. Yeah, okay. Silk has an API. Okay, so Kellen's answering. Silk has an API. Okay, and Kellen has indeed worked more with Silk than with than anything else. So we do have a message from NYOUG, and is anybody out there?
Any questions for
Still here,
Tim?
Tim. We're still here.
Okay, great. Wasn't sure. Are there any verbal questions to ask before I guess we finish, or are we finished?
Yep, this is pretty much it. So any questions? While you think of some questions for everyone, I'm just going to remind you all that, yes, this is being recorded. If you just joined us late, you will get an email follow-up that will show you how to rewatch today's sessions, and we'll try to get you slide decks from Kellen and Tim and all of those links. So we will set you guys up.
And if you do have additional questions, we've got email, LinkedIn, and Twitter handles. So
awesome.
Thank you so much.
Thank you so much, Tim. It was a great presentation, and we love having you. Hopefully you come back and speak for NYOUG another time. Same for you, Kellen. And everyone who joined us today, thank you so much. Join us tomorrow and Friday. If you've not signed up already, check it out.
Thank you.
There's some great comments coming in right now, but yes, it's going to be recorded and sent to you. And if you didn't RSVP to yesterday's, just send us a little note and we'll send you that. But I don't think a link has been sent out for yesterday's sessions. Thank you, guys.
Thank you.
All right, Tim, take care. Kellen, Tim, we miss you both. Hopefully we'll see you guys in person one of these days. Everyone, if you guys are not plugged into conferences coming back this session, there are a couple of user group conferences. Quest Community has their Blueprint 4D coming up in Vegas. ODTUG has K-Scope coming up in June in Dallas. So if you've not checked those out, I highly recommend them. You'll get speakers like Tim and Kellen, same quality, excellent folks. And I expect you get to spend a lot more quality time with them at some of these events. So thank you all. We'll see you tomorrow.
Thank you. Thank you, Coleman. Thank you, Monica. Bye-bye.
Take care.
Hi, everybody. Take care.